Welcome to this topic video covering security. Okay, and we're only talking web security, and we're not even going to cover it completely. It's a huge topic, but we got to start thinking about it, okay? Because it's going to be something that is always out there, always threats to our sites and our apps, okay? So we got to start thinking about this. And so let's start with an overview. And you should go take more security courses and things like that and read up on security. But let's just get started with this. Okay? So what we're going to understand and learn about is basic information security, also called InfoSec concepts. These are confidentiality, integrity, and availability. Okay? We're going to learn to understand the main website threats. Okay? And we're going to learn the fundamental concepts of access control. Okay. A long article on information security from Wikipedia. Okay. Basics of web application security for software developers, very coding oriented. A host of different web security articles and the Open Web Security Project, OWASP. Okay. Those are good references. Is there one good reading? I haven't found it yet. Okay. CIA. No, not the government agency, the U.S. government agency. This is a nice acronym to help us remember three fundamental concepts in information security: confidentiality, integrity, and availability. Okay. Let's go through each one of these. Okay. Confidentiality, so this is both from MDN and NIST. Confidentiality refers to protecting information from being accessed by unauthorized persons. Okay? In other words, only people who are authorized to do so can gain access to sensitive data. What do we mean by sensitive data? It could be your bank records. It could be your grades in my course. Okay, could be your health records. Okay, you should be able to access your grades in the course. Okay, and the teacher should be able to access your grades in the course because he's grading you or she. Okay, but nobody else should. Just like at a bank, you can see your bank records, and an employee at the bank who is helping you should be able to. Okay. A failure to maintain confidentiality means that somebody who shouldn't have access to that information has managed to get it, okay, by accident or intentionally. Okay. A failure of confidentiality is commonly known as a breach. Okay. And once they happen, it's done. Okay. Once the secret's out, there's no way to unreveal it. Okay. If your bank records are posted on a public website, everybody knows your bank account number, your balance, etc., credit card information, and others. It can't be erased because it's already been released. Okay. Nearly all of the major security reports, incidents reported in the media today, involve major losses of confidentiality. We hear about website hacks. People steal credit cards. People steal passwords and logins, etc. Okay. Confidentiality. It's because of confidentiality we need HTTPS. Hypertext Transfer Protocol. Yes, we know Hypertext Transfer Protocol, Professor. We've been using it. The secure version. Okay. The encrypted version. Okay. All HTTP traffic is visible when on the network. Oh yeah. There's no encryption. There's no hiding. There's nothing. Even the login password fields on like forms, those aren't encrypted by the browser. They put in those little dots there so somebody can't look over your shoulder and see your password. Okay? But when this stuff goes on the net, none of this stuff is encrypted. Okay? How many IP hops are there from your browser to a site? Okay? There are programs that will actually show you this. Traceroute is a general one for Linux, Unix machines, and PathPing used to be available on Windows. I'm not sure if it still is. So I did this exercise a while back on my machine, to see how many hops it takes to get to Grotto networking from my desktop. Okay, so I started. Okay, and I see one, my local LAN going out. Okay, all these different things, all these hops, blah blah. It was like about 14 hops to finally get to my website. Okay. If that traffic is unencrypted, every single one of those routers can see it. Okay. The problem is, not only are there a whole mess of routers between here and there, but traceroute only shows routers. There's a lot more devices in the network besides that. Lower layer switching devices, such as Ethernet, MPLS, and software-defined networking devices, don't even show up in traceroute. Neither do optical networking. That's way lower down. Okay. SDN, and a typical thing I would teach back in my networking class, where we do some SDN stuff, is setting up special entries to do packet intercept. So we can, okay. You do that for quality purposes at carriers, at ISPs, and you also do it to keep an eye out on traffic from folks that are trying to hack your network too. Okay, so it's very easy to grab traffic if you're in the right place to do it. Okay, so that's why we need HTTPS. Okay, otherwise we have no confidentiality. Okay, so if you go up to your browser and you see that you aren't using HTTPS, that really means everything between you and that website you're talking to can be seen by other people. Okay, they'll know what you're Googling for and stuff like that. Okay, that's why every website really should be using HTTPS. Integrity, the I in CIA, okay, refers to ensuring that the authenticity of the information, okay, that is, the information is not altered, and that the source of the information is genuine. Who it's coming from is who they claim to be. Okay. Imagine you have a website and you sell products on the website. Now imagine an attacker can shop on your website and maliciously alter the prices of the products. Okay, so they can buy anything for whatever price they choose. That would be violating the integrity. Okay. Other more nefarious things. I mean, this is a classic. Other more nefarious things is when you try and connect to a website, and through some mean, a malicious hacker is able to get between you and the website and somehow redirects your traffic to a lookalike website. Okay, this is like phishing attacks that you get via email. Okay, the site you're going to isn't genuine. It's not who they say they are. Okay, that's a lack of integrity. Okay, so we have cryptographic means of guarding against some of these, but not all. Okay, so integrity. Has the data been altered? Is it coming from who it claims to be? Well, it's great to have confidentiality. It's great to have integrity. But what if your system doesn't even work? Okay, that's the A in CIA is availability. Okay, for the information system to serve its purpose, it's got to be available. The information must be available. Okay, so there's a whole set of attacks, right? Current malware attacks where they denial of service, where they encrypt your data and they make you pay a ransom to unencrypt it. Other types of attacks are like denial of service attacks, like in distributed denial of service attacks, where they flood the system, the target system, with incoming messages, essentially shutting it down or overwhelming it so legitimate traffic can't get in. Okay, so availability. So this is the simplest A nice simple way of classifying things. Confidentiality, integrity, availability. Each one of these is a deep concept, okay, and a lot of aspects to it, okay. Different people sometimes worry about these in way different ways. In the optical networking world, we were super concerned with availability and making sure something went wrong, we could recover very, very quickly. Why? Because a single optical fiber can carry so much data, entire metropolitan areas and such. Okay, so the consequences of lack of availability could be huge in that case. Okay, so how do we ensure confidentiality and integrity? Well, we need a way to make sure only people that can do things are allowed to do things. So we have access control. We control who can see and modify the data. Okay? The most common way of providing access control is a trio, okay, of authentication, authorization, and accounting. What's accounting about? We'll get to that. We'll get to that. Authentication is the act of verifying a claim of identity. Who are you? Are you really who you say you are? Okay? Should I trust that you say who you say you are? Okay? Authentication. In the old days, okay, when you used to go into a bank to make a withdrawal, you'd tell the bank teller that you were somebody. You'd show them some kind of ID. Okay? This is the old-fashioned way to try and verify things. Okay? I know. Nowadays we know all those things could be hacked. Okay? But that was a way of claiming I am so-and-so, and then I prove it with some documentation. Okay? How do we do that nowadays? Well, there's three general ways that we can use to authenticate who we are or what something is. Something you know, like a PIN or a password. Something you have, like a driver's license, a cell phone, a magnetic swipe card, one of those token thingies, okay? Something you are. Biometrics, such as fingerprints, retina scans, eye scans, all sorts of things. Okay, this used to be like kind of futuristic, and now modern cell phones all have fingerprint checks and stuff like that. In the gym that we used to be able to go to would check, when we check in, you put your fingerprint down so they could verify it was you going in. Okay, so something you know, something you have, something you are. Okay. Multi-factor authentication. For stronger authentication, multiple pieces of authentication information can be used, including those from multiple categories. What we know, like a PIN, what we have, our credit card, what we are, a fingerprint. Okay. And there's tools to do this. There's tools to do this with websites and such like that. Okay. YouTube, GitHub, various places now offer multi-factor authentication to make sure those modifying things or seeing things are actually who they say they are. Okay. Now, once you're authenticated, what are you allowed to do? What should you be allowed to do? That's authorization. Okay. So after, okay, what are you permitted to access? What can you see? Okay. I'm a student. I've logged into my learning management system. I'm allowed to see my grades in my class. I can't see other students' grades. The teacher, on the other hand, when they've logged into the learning management system, they're allowed not only to see all the student grades, but change the student grades. Very different levels of authorization for different users. Okay. Authorization systems. Okay. One of the most common authorization approaches is something called role-based access control, RBAC. Okay? An example of that is like our learning management system, BlackBoard, okay, where there's administrators, there's students, there's teachers, and there's graders, okay? So I have a grader sometimes who will grade my students' submissions, okay? They can change certain grades, homework grades usually, not necessarily test grades. Students are allowed to go see their grades. Teachers are allowed to put up course materials, do all sorts of things. However, there are limits to what a teacher can do. They can't mess with the learning management system in general. That's for administrators. Teachers are restricted to doing things only on the classes they teach. Okay? So that's a full and complicated role-based access control. Other types of authorization systems, okay, or access control. Other ones that you may have seen or be familiar with are like file permissions, like Linux. You have like the user, the group, and other permissions. Something called access control lists, ACLs, you see, are commonly used in firewalls and routers. All these are access control systems or authorization systems. Okay. First thing that happens though is authentication. Who is it that's trying to do something? Then the next step is we can determine what they are allowed to do. Okay, now, all that's great, but the best systems can go wrong. So what is it we do to keep an eye on things? We have accounting. No, we're not talking about dollars and cents. We're talking about keeping an eye on who's logging in. Okay, and how are the systems doing? So we log, and we're familiar from this with HTTP and our servers, we log incoming requests, we log sign-ons, okay? We monitor, determine, and keep an eye on those things, determine who's using the systems, how are they using the systems, and is that use appropriate? How many false bad login attempts? Is somebody trying to crack a password for a particular user? Okay. That's very important to figure out what's happened. Okay. We have to be careful here because we get into privacy issues here once we are monitoring things. Okay. But if you're watching your website and you're seeing who's coming in, okay, and you're looking at the logs, that's a completely legit use. It's your website. Those visiting your website are coming to your website to visit it. You should definitely be looking at the logs. Okay, you will learn something by looking at those logs. What I learned is out of 1 million hits a year I get to my little website, half of those are attacks. Not sophisticated attacks, but what we call script kiddie attacks, meaning as soon as they're trying to check to see if I have a WordPress site and left the admin password to the default. Okay, those kind of attacks, as soon as a website goes up, people will see that and they will go and run a script against it. Those are called script kiddie attacks. You better guard yourself against those kind of attacks. Okay, more sophisticated attacks, another story. Those are harder to deal with. So getting down to that, what are threats? Okay, any mechanism or technique that can intentionally or accidentally compromise the confidentiality, integrity, or availability of a system. Yeah, you tripped over the cord connecting your server to power. That's a threat. Don't do that. Don't run power cables that way. Okay. Threat classification. People tend to classify that. Some of them are very broad, some of them are very narrow, some stem from particular approaches or specific attack vectors. This is a huge area, okay? But it's good to get familiar. Now, the Open Web Application Security Project, okay, has tracked those threats over time. And they post the top 10, okay, and select the top 10 to educate folks as the problems, not to help people hack things, but to tell developers how to avoid problems. Okay, so let's take a quick look at these things. Here's some more application, more detailed information that you can go get and read. Okay, top 10, 1 through 4. Injection, broken authentication, sensitive data exposure. Okay, injection. Any place, oops, let me make sure. Okay. Any place you can inject, you can add to a website. We type in, we add like a blog entry or things like that. Anytime data comes in, you have to guard against the possibility that that data may be an attempt to subvert the website. Okay? And this was overlooked in the early days of the web. We'd have something and say, here, you can enter your text here in this nice GUI editor, or here, you can put in plain HTML. You go put in plain HTML, and you wanted to put in this cool widget, you could put JavaScript in your plain HTML to do something cool, right? Whoa, wait a second. If they allow you to put in plain HTML, and that includes JavaScript, that means you can just inject code. What's the other type of hacks? For those people that deal with databases, there were ways to sneak in through just the form inputs and stuff. You could masquerade and put in the right special characters to actually issue what are database use a language called SQL. You could actually sneak in SQL commands. Really, seriously. This was all software's fault. Okay, you can't blame the web server even. Okay, broken authentication. We don't do it right. Okay, there's a lot of ways that we can deal with passwords wrong. Okay, we can leave, and this is a common thing that happens. I know it sounds silly, but you can just leave sensitive data available to be exposed. It can be sitting on a server, okay, where you didn't encrypt it, or you didn't put in proper checks to who could go and look at it. You have a bucket on some cloud server provider, and you didn't make it private, and so everybody in the world can look at this data. Okay, sensitive data exposure is easier than you might think. Okay, broken access control. What does that mean? Well, somebody logs in. Okay, I log into some system, and okay, it made me log in, but they forgot to really check the difference between an admin and a regular user, so somehow I can go and turn myself into an admin. Okay, so that's one form of broken access control. Okay, things like that. Okay, other things, cross-site scripting, misconfiguration of security, real easy to do with complicated systems. Okay, some of these don't apply to us, but we're using a lot of open source subsystems, using components with known vulnerabilities. This is what people talk about when they talk about patch management. We're using a lot of libraries when we build our servers and when we're building our front-end apps. We've got to be on the lookout. When NPM tells us that some packages are out of date, we better pay attention. Third thing is not logging and monitoring those logs. Okay, so applicability of OWASP, these ideas to my classes. Okay, first of all, our application project, what we've been working towards all semester, is supposed to support multiple users with different roles. Okay, we're doing a club site, we're doing a tour company, or we're doing something like that. Okay, or you're doing your own thing that meets these criteria for my class. Okay, they're going to be both private and shared information. Users have different roles. Okay, and users are going to create and modify information via the application or website. Okay, that is a microcosm of a general website, web app, right? Multiple users private and public data, different roles, okay? Injection. Almost any source of data can be an injection vector, an attack vector, okay? So this is almost entirely a developer issue, okay? The person running the firewalls in front of your, the networking stuff and the firewalls in front of your server, or running and keeping an eye on the, say, the server that sits before your server, they can't help you here, okay? This is your code, okay? This is your server code. If it's taking and not checking that data that's coming in for these kind of problems, that's up to you. Broken authentication, okay? Attackers have access to lots of things that they can use to try, okay, to break through authentication, okay? We have to help. We have to do the right things, okay? It's not do the super wrong things, and we have to encourage our users to do the right things, okay? We're going to get more into this because we're going to have special things we have to do in this class. You must always do in real world about dealing with passwords, okay? And we'll learn about that in a separate talk coming up, okay? We're the ones that implement this stuff, okay? There's this thing called session management, which is kind of the bedrock of authentication. That's all done in the server and software and systems that developers deal with, okay? Not security professionals, okay? But security professionals know about attacks, they know about all sorts of different things, but they don't know how to write your code for you, okay? And you then you have a big responsibility for things like authentication and authorization, okay? So you've got to learn enough about that to do it right, okay? Or read up or ask questions when you do it, okay? We must implement our access controls, authentication, authorization, okay? We have to implement session management to help us enable this, okay? That's all on us, okay? A quick overview of general security, information security concepts, and issues that pertain to us as web developers.